All right, guys, today is Chapter 9, Lesson 4, Direct Variation. Bear with me, this is probably going to get a little long just because there's so much teaching involved in this lesson. Couple things. So yesterday you worked on slope, and slope has another name. It's also called constant of variation. Okay, and slope, and if you listened to my video yesterday, I said that slope is often referred to as m. So a lot of times when you're finding slope, you actually write m equals and then your answer. To find a slope, if you can take y and divide it by x in your equation here, you should be able to find your slope. If it is in this format, y equals mx, if you read over here, if it has that y equals mx format, then it has direct variation. So if I were to jump down to here, if I were to have to answer, does this have direct variation? Because it is in the y equals, and then this is your slope, mx, we would say yes. If I look at this equation here, y equals, and then here's my slope, so it would be mx plus something. The minute you start to add something, it's going to change it, and no longer will it be direct variation. So this answer is no. Sometimes you'll be given an equation, and you can answer it by yes or no if there's direct variation. Sometimes they're going to ask you, well, about a graph, and if you look at the graph, is there direct variation? So the rule is, for a graph, there is direct variation if the line is straight and goes through the origin. So if anyone has forgotten, the origin is right here where the x and the y axis intercept each other. If you're looking here, I'm going to highlight this one in blue. So this line is straight, but it does not go through the origin. So this information goes with that line. So there's no direct variation because the line does not go through the origin. Then I'm going to highlight this one a little more reddish. This line has direct variation because the line is straight and it goes through the origin. So again, look at your notes here if that helps you. I'm going to go now through some of the problems. So now let's try a new worksheet and get it all lined up here. Sorry guys, I'll do my best. All right, so it says, recall the graph from lesson 9-3 of the circular design, which I don't believe we did. Let's see, the design had two circles, one that is decreasing in the size of the circle, which is this circle 1 right here, and one that is increasing in size, which is circle 2. So this was increasing in size, this was decreasing in size. It says, for number 1, determine if the relationship between the number of seconds, so here's the seconds, and the radius, so here's your radius, has direct variation for circle 1. So I'm going to circle 1 here so you know which one I'm talking about. It's this line. So the directions in our notes said, to tell if a graph has direct variation, the line has to be straight and it goes through the origin. And it is a straight line, but it does not go through the origin. So therefore, this answer would be no. The next one, number 2, determine if the relationship between the number of seconds, so again, here's your seconds, and the radius of the circle, and we're talking about circle 2 now, has direct variation. So again, this line here is straight and it goes through the origin, therefore, yes. So this line has direct variation because the line is straight and goes through the origin. Remember, the other part of the lesson was, if your equation is in the format y equals mx, and if you even noticed in your notes, to find out what slope is, and we looked at this very quickly, if you take y and divide it by x from here, that will help you determine what is your slope. Whoops, I'm sorry, I cut that off. All right, I'm gonna go ahead, push this up and start working on number 2. It says the equation y equals 750x represents the number of dollars y Olivia earns in x weeks. Determine if there's a constant of variation. If so, explain what it represents. Again, in our notes, we said slope is also known as the constant of variation. All right, I'm just abbreviating. So is this in that y equals mx plus b format? Or sorry, y equals mx. It is, so therefore, yes, it has direct variation. Direct variation. All right. What is the constant of variation? So the constant of variation equals, again, whatever the slope is. And if it's in this format, it is that value right there in front of the x. So in this format, your slope or your constant of variation is 750. And then if it does have the constant of variation, which it does, 750, what does it represent? Some of you guys really have to start reading the directions because you're missing out on some of the explanations and you're going to start losing more and more points. So what does this represent? Well, it represents, so you'd write a sentence, and I'm not going to because it'll take me too long, something about Olivia's earning $750 every single week. That would be what you could write it as. All right, we're going to move on to number 3 now. Number 3, the length that a spring stretches varies directly with the amount of weight. So if you guys remember, if you're thinking about a graph, this is your y. Y always depends on your x, okay? And y is dependent, or it varies depending on what happens to x. So when they told us that the spring stretches, the length that a spring stretches varies directly with the amount of weight it is attached to. So here's my weight, and that's going to be my x value, and the amount it stretches is going to be my y value. All right. They told me 8 ounces for my x, 2 inches for my y. So if I have this right here, remember, I'm going to plug in x for 8, and I'm going to plug in 2 for y. And for me to figure out what the slope is, if I take my y, which is a 2, and divide it by x, which is the 8, that should give me my slope. Now I think you should still reduce this and get 1/4. So 1/4 is your slope. So it says write an equation relating a weight x and the amount of stretchy y. So that would kind of be what we were starting here. So we'd write 2 equals m times 8. And then next, we went ahead and said you could keep it that way, or you could rewrite it. Sorry guys, I know this is tricky. I wish I was with you helping you out. To figure out what the m was, you went ahead and solved it and got 1/4. So you could instead write y equals 1/4 x. And honestly, you can cross this off. That probably doesn't make as much sense to you guys yet. All right, now we have our equation. Now we are given there is a 20-ounce weight attached. So remember, our weight is right here, and that's our x. So we are going to now plug in 20x. So y equals 1/4 of 20, which will give me y equals 5 inches. Please join me for the Google chat today. I think it would be easier if I could just talk with you guys and answer questions as you go through it. Otherwise, hopefully this will help you guys a little bit. Good luck.